So good afternoon to everyone. We are going to start today the effect of harmonics on the induction motor drive. Okay, so we are giving a three-phase supply to the induction motor. Now this three-phase supply is given at a frequency of 50 Hz. If we will give the supply to the induction motor through a voltage source inverter or a three-phase inverter, so the input voltage will not be sinusoidal, rather it will be a square wave kind of thing, and these square waves generate lot of harmonics. In other words, we are learning what is the effect of unbalance, what is the effect of three-phase supply at different frequencies, or what is the effect of three-phase supply if it is given through a voltage source inverter. Okay, so let's say is used. This VSI objective is to convert the DC voltage. So input is VDC. So DC voltage is converted into a three-phase AC. In this situation, induction motor, in this situation, what will be the effect on the induction motor? Is it going to rotate in the sinusoidal, or it has got some effects? What is the drawback? The drawback is in this situation, we are not giving a sinusoidal input. We are giving a input of different harmonics. We are here giving an input of, let us say, VAN or VRN. What is it? Vm sine of omega t, correct? What is VBN? VBN is equals to Vm sine of omega t minus 120. Phase displaced in time by an angle of 120 degree. What is VCN? VCN is equal to Vm sine of omega t minus 240. हम लोग इसको बोल सकते हैं minus 240, or we can say that plus 120. Plus 120. We can go for this. This is a sinusoidal waveform. Very good. But when we are giving the input through an inverter, our output voltage is coming like this. It is no longer a sinusoidal waveform. Rather, it is a square waveform. In any phase, you will get a square waveform kind of things. This square waveform is a combination of fundamental, that is a first frequency of fundamental first order harmonic, then third, then fifth, then seventh, and like that. If I will draw the harmonic profile of this square waveform, it will look like this. If I will draw the harmonic profile, you will get a fundamental wave component, that is a first harmonic. This is first, which is actually required for us. The value of this peak value is 4 Vm by pi. If it is a single phase square wave in that situation, so it has got a fundamental component, then it has got a second, no, third, yes. So it has got a third harmonic component, then fourth, then fifth, it has got a fifth harmonic component. Like that, you will find that it has got a seventh harmonic, then eighth, ninth harmonic, and like that you will have got a different harmonics present in the input. This person, the fundamental, is very good for us because this is the one who is responsible for providing the torque, forward motion. What is the effect of third harmonic? That we will study. What is the effect of fifth harmonic? We will study, and the seventh harmonic, because these are the dominating frequencies. The frequencies which is beyond 9 and 11 and 15, or beyond 19, the frequencies which is beyond 19th order are very less effective, because with the increase in the frequency, their magnitude is also decreasing. If this magnitude is 1, if the magnitude of this fundamental is 1, this magnitude of the third harmonic is 1 by 3. Magnitude of the fifth harmonic is 1 by 5. Magnitude of seventh harmonic is 1 by 7. And similarly 1 by 9. So you can imagine that what is the harmonics, what is the magnitude of 19th harmonic? 1 by 19, very less. So we will say neglect. Let us study for these things, which is usually asked in the objective question. What is the effect of third harmonic, fifth harmonic, seventh harmonic, and ninth harmonic onwards? Right? So these three are the most important, which is asked. What is the effect of third, fifth, and seventh? So to show that what is the effect, let us see the equation first. This is the equation for fundamental, correct? Let me zoom this up. Okay, this is for fundamental. If I will write the equation for the fifth harmonic, next is third harmonic, V3AN, or let us write VAN3, third harmonic. This is equal to VM3. VM3 is 1/3 of the VM into sine of 3 omega t, because the frequency is increased by how many times? 3 times. So 3 omega t. What is VBN? VBN third harmonic will be equals to VM3 sine of 3 omega t minus 3 times of 120. Minus 3 times of 120. This is the effect of, this is VBN 3. What is VCN3? VCN3 is VM3 sine of 3 omega t plus 120. So I can write plus 3 into 120. You will observe here that this quantity is 360. This quantity is 360. If this quantity is 360, what I can write, say that I can rub this out. And I will say that, okay, this is like this. What do you understand if the three-phase voltages is given now? This is the input waveform. One is VAN, VBN, and VCN3. So we are finding that they are not displaced from each other by an angle of 120. Rather, they are called co-phasors. These are called co-phasors. Just like we have a single-phase supply here. So you bring 3 single-phase supply and give it to induction motor, it is of no use, because these are co-phasors. They are not displaced from each other by an angle of 120, co-phasor. So this is good for nothing. This current is there, but this will not produce any torque. This will not contribute anything. Okay? So it is self-understood. If similarly, we can also proceed for VAN5. So you can now also write the equation for VAN5. What will it be? VM5 sine of 5 omega t. Can we write 5 omega t? Similarly, we can also write VBN is equals to VBN5 is equal to VM5 sine of 5 omega t minus 5 into 120. It is 5 into 120, correct? So 5 into 120 means how much? 3 into 120, 360. 5 into, then another 2 is 240. So I can write instead of 5 into 120 minus of 240. So इसको हम लोग लिख सकते हैं minus 240 या फिर plus 120. So I will remove this and say, okay, this is plus 120. Clear? Clear? Next, what is VCN 5? VCN 5 is equal to VM5 sine of 5 omega t. Plus is there, so plus 5 into 120. What is 5 into 120? 3 into 120 gone, right? 2 into 120 is 240. So plus 240, either plus 240 or minus 120, which, okay. So we can write it like 5 omega t minus 120, correct? So here we are getting VAN5, VBN5, VCN5. What do you find it here? This is one kind of rotation. Here the phase sequence is ABC. Here cophasor. Here It is not ABC, it is rather ACB. So it will produce a flux which is rotating in the anti-clockwise. If it is rotating in the clockwise, this is anti-clockwise. You can assume that, sir, if this is anti-clockwise, this is clockwise. Okay? So we understood that fifth harmonic is producing a flux, but it is not in the same phase as a fundamental, but in opposite phase. What is the effect of seventh harmonic? Check. Can we check now what is the effect of seventh harmonic? VAN7, so you will get VM7 sine of 7 omega t, correct? Okay, so VBN7 is equal to VM7 sine of 7 omega t minus 120. So minus 120 into 7. So if I will multiply 120 with 3, it is 360. So jodi mu taku multiply karibi 6 re, it is again 360 multiple. Banchla kete 1, matlab 3 plus 1 है 7 है. So 1 into 120, so equivalent to mu jodi 1 into 120 karibi saman achi. Rather than I will write 1 minus 1 into 120, that is minus 120. Similarly, we can write VCN7 is equals to VM7 sine of 7 omega t plus 120. Because I will multiply 1 instead of 7, I will multiply only 1. That is okay. It is okay, right? So what is the observation here? If the harmonics is of order 3, it is good of nothing. It is cophasors. If the harmonic is of order 5, odd harmonics of order 5, it will produce a flux which is reverse of the fundamental. Harmonic of order 11, it will produce a flux of same phase. So this is the information we get, right? So can we make some kind of summary out of it? We know the calculation of the slip is, how do you calculate the slip? The slip is equal to omega ms minus omega m divided by omega ms. Can we make a formula out of that? Is it equals to 1 minus omega m by omega ms? Can we write like this? So from this, can we write omega m by omega ms is equals to 1 minus s? Can we say this is a formula? Correct? We will use this formula to evaluate what is the slip if the harmonics is third harmonic, right? So let us say S3. S3, there is no use of calculating the slip S3 because omega ms is not there, right? So this is gone, right? So slip will not exist for that. What next is S5. What is S5? S5 will be 5 times of the fundamental frequency. Instead of omega ms, I can write 5 times of omega ms minus omega m divided by 5 times of omega ms. But also we know that this omega ms is negative, reverse. So can I say this is like this, minus and minus over here? Because the synchronous speed is not in the forward direction, is in the reverse direction. So instead of omega ms, we can write minus of omega ms and multiply that term with 5 because it is 5 times of the synchronous speed. Can we just shuffle this up? This can be written as 1 plus omega m by 5 omega ms. Is it right? What is the value of omega by omega ms? 1 minus s. So what we will do, we will say that this is 1 plus 1 minus s divided by 5. Can we write like this? Now, this will be equals to 5. Okay, just evaluate this. 5 plus 1 minus s by 5. So we can say that this is 6 minus s by 5. This is the value of S5. So what we can summarize this, S5 is equals to 6 minus S by 5. So can you calculate what is the value of S7 now? What will be the value of S7? In the same way, you please calculate. And remember, S7 is S times 7 times of omega ms and positive because it is rotating in the forward direction. And tell me what is the value of S7 from that? Instead of minus 5, it will be 7. Here also it will be 7. So it will be 1 plus omega ms by 7. This will be, instead of plus, it will be minus. So now this will be minus over here. This is 1 minus s. This is multiplied with 7. So instead of 5, 6 plus s by 7. Very good. This is equals to 6 plus s by 7. Now tell me, what is the value of s? How does it vary? It varies from s is equal to 0 to s is equal to 1. S is equal to 0 to 1. If I will vary s is equal to 0 to 1, this will be approximate equals to 1. So these things, so these values are approximately equals to 1. Okay? I'm going to put this in the equivalent circuit. Okay? Okay, this is understood, right? Okay. Just recall the equivalent circuit. How does it look like? The equivalent circuit, you have got a primary resistance, then reactance, then, this is leakage reactance, X1, R1, then XM. Here you have got X2 dash, and here you have got a resistance. We can say R2 dash by S. And this is the input voltage is V, where all the terms are per phase quantity. When I say we are giving a sinusoidal voltage, this is okay. But when we are saying we are not giving a sinusoidal, we are giving a square kind of waveform, which is the worst waveform, then the same input voltage as per the Fourier series analysis, the same input can be written as, suppose V0 theta is equals to VDC plus VAN cos of n omega t plus VBN sine of n omega t, where this is summation of n is equal to 1 to infinity. This is the Fourier series, except for a square wave, if you find, you will get this is equal to Vm1 sine omega t plus Vm3 sine 3 omega t plus Vm5 sine 5 omega t plus Vm7 sine 7 omega t plus so and so. That means a square wave is a combination of fundamental plus third harmonic plus fifth harmonic plus seventh harmonic plus ninth harmonic, like that. माने मु देइथेबी 100 वोल्ट ता भितरे 90 वोल्ट सपोज हेतो फंडामेंटल, बाकी किछि हेतो थर्ड, बाकी किछि एमती फिफ्थ, बाकी सेवेंथ, एमती सब की डिस्ट्रीब्यूट हेतो माने मु दिल्ली 100 पाइली केते 90 आउट ऑफ 100 मुझे कितना मिला 90. ये जो 90 है ये तो मैं काम में लगा दूंगा. नो प्रॉब्लम। पर ये जो बाकी जो बचा 10 में से डिवीजन हो गया, इसको कुछ ऐसे है, ये लोग प्रॉब्लम भी कर रहे हैं। ये थर्ड हार्मोनिक कोई काम कर नहीं, द थर्ड हार्मोनिक इट इज गुड फॉर नथिंग, गया। फिफ्थ हार्मोनिक, दिस गाय इज अपोजिंग द मेन वेवफॉर्म, ही इज ट्राइंग टू अपोज मी। फंडामेंटल ओके, स्क्वायर वेव के कारण फंडामेंटल कम हो गया, ओके, बट थर्ड हार्मोनिक काम नहीं कर रहा, ओके। फिफ्थ हार्मोनिक इज अपोजिंग इट, दैट्स नॉट ओके। अब बोलेगे सर सेवेंथ हार्मोनिक इज इन फेवर ऑफ इट, इज इट ओके? दैट ऑल्सो नॉट ओके। क्योंकि हम आप किसी चीज को आप घुमा रहे हो, तो आप जिस रिदम से घुमा रहे हो, अभी एक छोटा सा बच्चा आएगा, वो भी घुमाने की कोशिश करेगा, एंड उसका हाथ अगर आगे पीछे होगा तो आपका जो रिदम है वो रिदम खराब हो जाएगा। So if you are using a very precise motor where the motion should be very good, sinusoidal and smooth, these seventh harmonics, fifth harmonics are the disturbances. So that's why we using a filter or using a modulation technique to remove this all harmonics. However, we are learning what is the effect of third, what is the effect of fifth, 2 marks question. What is the effect of seventh? अगर तुम्हारा मोटर में कुछ परफॉर्मेंस खराब दिख रहा है, तो आप उसका जो स्पीड परफॉर्मेंस को देखकर बता सकते हो कि सप्लाई में कहीं पर प्रॉब्लम है। बिकॉज एज ए इंजीनियर व्हेन यू वर्क इन द प्लांट, you cannot see the input waveform because input waveform is coming from transmission line. तो आपको मोटर का जो वेवफॉर्म है उसका सिग्नेचर लेना है, उसका सिग्नेचर देख के बताना है कि इसका अगर सिग्नेचर साइनसॉइडल इनपुट होता तो ऐसा होता, अगर फिफ्थ हार्मोनिक गुस्सा है तो ऐसा सिग्नेचर है। तो सिग्नेचर देख के आप बता सकते हो कि सप्लाई में कहीं पर तार कहीं से लूज है, supply voltage is not balanced, it is unbalanced, therefore the harmonics is created and you are getting this kind of problem. That is the job of an engineer in the plant. Now what is the effect on the equivalent circuit? इस equivalent circuit को गौर से देखो, यहां पर जो वैल्यू है S, ये कितना है? Usually the value of S is 0.01 or 0.04. The value of S is equal to 0.04. If I divide by 0.04, this value is very high. If this is a decimal, this value is very, very high. So resistance is very high in front of the reactance. अगर resistive load है तो आपका पावर फैक्टर अच्छा होगा, अगर रेजिस्टेंस कम है तो पावर फैक्टर खराब होगा। कैसे खराब होगा? Now instead of that, if I will say now the new resistance is R2 dash by S5. What is the approximate value of S5? 1. पहले कितना था? 0.02, 0.04. अभी कितना है? 1. So R2 dash वैसे ही रहा. This value is now small in compared to X2 dash. So now the equivalent circuit, we can say, now the equivalent circuit for this harmonics will be, this is R1. Let us say harmonics of frequency, new frequency is m times of the fundamental. So this is Fm. So we can say, let us say this is Xm. Reactance is equals to 2 pi Fm, correct? Into L. L is constant. So if frequency increases, Fm will increase, and Fm will increase, so Xm will increase. So we will write here X1m. Finish this side Xm. Usually we say Xm, this is m. For the frequency it is okay, we will say m times of Xm. Sorry, here also we will say m times of X1, correct? Now it is okay. Other side, this is X2 dash m times, because m is multiplied with the, here m is multiplied na, so this is equals to m times of X1, right? So जहां जहां पर रिएक्टेंस है वहां m मल्टीप्लाई हो जाएगा, यहां पर भी m मल्टीप्लाई हो गया, एंड रेजिस्टेंस का क्या होगा? What will happen to resistance? R2 dash by Sm. And what is the supply? Supply voltage is fixed, is V. So this is the situation for different harmonics. So what is happening here? For the other harmonics, if I will say for Vm, where Vm is equals to 3 or m is equal to 5, 3 तो कुछ नहीं काम करेगा, because 3 का तो इफेक्ट ही नहीं है, क्योंकि आप 3 सिंगल फेज दोगे, it is of good for nothing. When m is equal to 5, 7, 9 is also good for nothing. Why? Can anybody tell? Why 9 is also not good for anything? If 3 is co-phasor, multiple of any 3 is also co-phasor. अगर 3 कुछ काम नहीं करेगा तो multiple of 3, 9, odd number, he will not work. Multiple of 3, 15, again not work. So suppose the objective question is there, 9, what is the effect of 9th harmonic on the induction motor? Or 15th harmonic in the induction motor? Or 21st harmonic in the induction motor? So null. Why? Because these are co-phasors. Tell the answer, justify answer. Because these are co-phasors. How co-phasor? Because they are not displaced from each other by angle of 120. They are in phase. So if it is in phase, or the value of S is 1, so we find the thing is very, very inductive. This is highly inductive. If it is inductive, what is the problem? It will be a lag, it is lagging. The current will be lagging the supply voltage to a much more extent. If I will draw the phasor diagram, suppose this is the supply voltage V. If V1 is here, V5 will be here. Sorry. If I1 will be here, I5 will be here. And I5 will be here. I7 will be here. It's lagging in nature. The magnitude of the current is decreasing, no doubt. But because of lagging nature, it will draw more current from the source. So these harmonics are very dangerous. That is why when you make a robot or some kind of things, you must have a very good sinusoidal input waveform. Or else it will create one kind of fluctuation in the motoring mode, right? So these are the effect of harmonics, and what are the slips, all these things we learn. Okay, so next we will learn what is the effect of unbalanced voltage. Till now we are learning if the voltage is, instead of sinusoidal, it is a square wave, how we will handle the square wave. Now we will learn how we will handle an unbalanced voltage, because unbalanced voltage leads to unbalanced current. Unbalanced voltage कैसा है? जैसे अभी आप 3 टेबल में खड़े हो, राइट? 3 रो है, वहां पर 6 स्टूडेंट्स, यहाँ पर 4 स्टूडेंट, दिस इज 2 स्टूडेंट. So magnitude of this side is 2, this is 4, this is 6. This is unbalanced. So okay, so that's why I've shared you a video where we discuss about a balanced and unbalanced load. Let me give an example. Suppose the voltage is VAN, VBN and VCN. This is time displaced. Remember, this is time displaced by an angle of 120 degree. The motion is this side, omega ms. In time, VAN is Vm sin omega t. In time, VBN is Vm sin omega t minus 120. In time, Vm sin omega t minus 240. Now point is that if this is the positive sequence, this is balanced positive sequence. What is unbalanced? If the same thing is given in this way, VAN is like this, VBN, VCN are like this. Supply voltage, because of some disturbance, A phase is half. As an engineer in the plant, you will come to know later. First, the motor will behave different. So from the behavior of the motor, can you tell that which phase is having a problem? You can have another problem like this. Suppose you have got another problem VAN is here, VBN is as it place, VCN is as it is place. All are equal magnitude. VAN is also same, VBN is same, VCN is same, equal magnitude. But VAN is not aligned with the 0 degree. Here it is called unbalance. This is unbalanced because of not aligning by 120 degree out of phase. This is unbalanced because the magnitude is not in phase. That's why magnitude is not equal. That is why we have in the power quality, one numerical is given in that video where the magnitude is given in per unit quantity as 1 pu. So if this is 1 pu, this is 1 pu, this is 0.5 pu per unit. And all are 0 degrees. Here all are 1, but this is not 0. It is 1 angle 30 degree. This is 1 angle. How do you say these angles? You will say this is, let us say this is 10 angle 0 degree. How much this is? 10 angle minus 120 degree. How much this is? 10 angle minus 240 degree. Remember the term Vm sin omega t. Vm sin omega t minus 120. Minus 120. Vm sin omega minus 240. Correct? So that is why they are displaced by an angle of 120. Clear? Now, what is this positive sequence, negative sequence and 0 sequence there? ये क्या चीज है? What is this? इस अनबैलेंस को समझने के लिए हमको वो तीनों चीज समझना है. जैसे ब्रह्मा विष्णु महेश्वर. Okay, every soul has got a positive atma. There is a good thing is there. There is a negative thing is there. There is a neutral thing is there. Correct? So if I can resolve ABC in terms of positive sequence, negative sequence and 0 sequence, let us do it like this. If this white one, okay, let me make a okay, white. This is VAN, VBN and VCN. Any three phase can be resolved into positive sequence, negative sequence and 0 sequence. Correct? The positive sequence, you can resemble it like, okay, this is a God side. So positive sequence is AN, VBN, VN, let us say 1, V1, VB1, VC1. These are the positive sequence voltages. Plus negative sequence, the negative sequence, let us see by the red one or here blue one, right? So negative sequence is same, VA2. Here VB2 is upward, VB2 and VC2 is here, VC2. 0 sequence, let us see the 0 sequence by the green line. This is VA0, VB0 and VC0. So this is the meaning of positive, negative and 0 sequence. Positive sequence, it is actually rotating in the anti-clockwise direction, omega ms. Negative sequence, same picture if I will keep it here, rotating in the clockwise or rotating in the anti-clockwise, but the sequence is changed. यहाँ पर हमने क्या किया? A, B, C. इधर, let us say rotating in the anti-clockwise, but A, C, B. या फिर same picture को यहाँ पर रख दो और इसको rotate करो in the anti-clockwise. I can draw it here once more. Just a minute. Let me draw it the same picture here. VA2, let us say VB2, VC2, but it is rotating in the clockwise. I can say the same yellow picture over here and say that it is rotating anti-clockwise or it is rotating clockwise, but it is not be perfect. Rather, I will say that this is a C, B, and it is rotating anti-clockwise. This is negative sequence. Zero sequence, 3 sinusoidal voltage, but they are not lagging from each other, they're co-phasors. So this is zero sequence. So if the supply voltage is balanced, this is one more question. Suppose supply voltage is balanced, what will be, let me first write down what is the equation, then I will ask you. What is the equation here? The equation is VAN is equals to VAN1 plus VAN2 plus VAN0 और V1, VA1, VA2, VA0, मतलब तीनों को मिलाकर होता है हमारा VA, करेक्ट? इसी तरह हम बोल सकते हैं VBN is equal to VB0. Okay, let me write with 1. VB1 plus VB2 plus VB0. Similarly, we can write for C also. यानी किसी भी इंसान का अगर मैं सोचूं दिस इज ब्रिजेश कुमार, it has got a 3 components. One positive sequence, another negative sequence, another zero sequence. If I am pure God, वो तो हो नहीं सकता. If I am pure God, so I have got only positive sequence. If I am a full devil, zero sequence भूल जाओ. Negative sequence. If I am somewhere like human, like I have got some 50% positive, 50% negative. But there is also a probability that I am unbalanced. In case of unbalance, so it has got some 90% suppose positive sequence, 8% suppose negative sequence, and zero sequence is 2. Zero sequence is not harmful, but this 8% negative, it will try to give me a problem. So इस तरह क्या होता है? What is the characteristics of positive, negative, zero sequence? ये तीनों बराबर एक दूसरे से 180 डिग्री में, 120 डिग्री में रहेंगे. नेगेटिव सीक्वेंस ये भी 120 डिग्री में रहेंगे. कोफेजर ये 0 डिग्री में रहेगा, ये कंफर्म है. So from this we can get a relation between VA, VB, I'm not writing N anymore. VC is equals to let me write first V0. Sorry. Don't write because this is already you have seen in the video there. I think you know it. VA1, VA2, VB0, VB1, VB2. VC0, VC1, VC2 is the sum of all the 3, right? So here I can say 1, 1, 1 at this point of time. Right? Matrix complete. Now, can I write VB0 as VA0? Tell and see that picture and tell me. Can I write VA0, VB0 is VA0? VC0 is also VA0. Can I write? क्योंकि ये तीनों तो बैलेंस है, ये तीनों कोफेजर है, तो can I write here instead of VB0? Can I write here VB0 is same as VA0? Can I say VC0 is same as VA0? VA0. So these are A0, A0, A0. Done. Similarly, can I write VB1? What is VB1 in terms of VA1? VA1 का पोजीशन कहां पर है? Where is the position of VA1? This is 1, right? Where is the position of VB1? -120 डिग्री में है. या फिर एंटी क्लॉकवाइज 240 डिग्री में है। सो हम लोग एक यूज करते हैं टर्म अल्फा। इन सम बुक इट इज ए। व्हाट इज ए? इट इज अ फैक्टर 1 into e to the power j120। यानी किसी भी वेक्टर को आप 120 डिग्री रोटेट करो तो दैट इज ए। 220 ए स्क्वेयर। सो अल्फा बोलो तो या फिर यू कैन से ए और अल्फा वॉट एवर इज सेम, राइट? तो ए VA1 को कितना डिग्री रोटेट करने से VV1 होगा? 240 डिग्रीज। सो 240 डिग्री कैन आई राइट दिस एज alpha square times of VA1. If this is alpha square times, what is VC1? Alpha times. So this is alpha times VA1. Easy. Next, A2 नेगेटिव सीक्वेंस। अगर VA2 वहां पर है तो VB2 कहां पर होगा? Where is VB2? Alpha times. So if it is alpha times, so remove this. Now it is alpha times VA2. What is this then? Alpha square times VA2. So let us take this term VA1, VA0, VA1 and VA2. Let us take outside and make the matrix clear. So we can write here VA, VB, VC is equals to 1 1 1 1 alpha square alpha 1 alpha alpha square times VA0, VA1, VA2. Is it done? You can match. VA is equal to VA0 plus VA1 plus VA2. What is VB? VA0 plus alpha square VA1 plus alpha into VA2. What is VC? VA0 plus alpha into VA1 alpha square VA2. This is a matrix. Can you write down what is the matrix for that? Inverse of this matrix. This is the matrix, done, right? So if I want to get VA0, VA1 and VA2, what I will write here? And this side will be VA, VB and VC. What shall I write here? This is the matrix A. You will do inverse of this matrix. You will get a matrix here. So you can do in your free time. I will tell you what is the inverse value. What is this? 1 by 3. This will be 1 1 1 1 alpha alpha square 1 alpha square alpha. Very easy. This will be like this, like 1 1 1 1 alpha alpha square 1 alpha square alpha. This way you can get what? You can get what is the value of VA0. अगर आपको जीरो सीक्वेंस मालूम पड़ गया किसी भी एक कंपोनेंट का, A0 मालूम पड़ गया तो B0 C0 मालूम हो गया. You can easily get. सिमिलरली VA1 अगर मालूम है तो VB1 भी मालूम हो जाएगा, VC1 भी मालूम हो जाएगा. सो एक एक कंपोनेंट, एक पॉजिटिव, जीरो और नेगेटिव सीक्वेंस का एक एक कंपोनेंट को पहले निकाल लेते हैं. हाउ टू फाइंड? दिस इज अ फॉर्मूला. तो VA0 इज 1/3 ऑफ समेशन ऑफ ABC. अब मुझे बताओ अगर VA, VB, VC तीनों बराबर हैं, व्हाट इज द वैल्यू ऑफ VA0? अगर VA, VB and VC all are equal, what is the value of VA0? You will say, sir, VA plus VB plus VC by 3. मैंने बताया कि तीनों बराबर है, पर बराबर होने के साथ और एक चीज मैंने क्वेश्चन में बोलना भूल गया. वो क्या था? ये बराबर है और एक दूसरे से फेज डिस्प्लेस में 120 डिग्री में डिस्प्लेस्ड है, मतलब दे आर बैलेंस्ड. If the question examiner asks you if ABC are all balanced, what is the value of VA0? What will be the value of VA0? कभी आपने ऐड किया है 1 angle 0 plus 1 angle minus 120 plus 1 angle 120 plus. What will be this value? I will show you here. What will the value? This will be 1, right? 1 angle minus 120. This will be minus 1 by 2 plus j root 3 by 2. 1 angle 120. Sorry, minus 120. This will be negative. 1 by 2 minus j root 3 by 2. 1 angle 120 कितना होगा? Minus 1 by 2 plus j root 3 by 2. Minus plus j root 3 by 2 minus j root 3 by 2 cancel each other, right? 1 minus of 1 by 2 minus of 1 by 2, 0. So this will be 0. So if it is a balance, then this will be 0. Correct? But if it is not balanced, then you will have a component. Suppose I will give you VA, VB, VC is equal to, in the examination, this is 220 angle 0. This is 220 angle, suppose instead of minus 120, I will write minus 125. And this is 220 angle minus 240 or plus 120 ki jagah plus 110. If I will write like this, you will use your calculator and find out VA0. Though it look very difficult, but it is very easy. Just आपको add करना है VA, VB and VC. If it is not 120, maybe it is some 125, you can put in calculator and get the value. Now you might be thinking that why all of a sudden we are learning this positive sequence, negative sequence and zero sequence. Why we are learning? Because we are giving a supply to the induction motor through a supply. That supply is usually 220 volt, sorry, three-phase supply. Three-phase supply, line to line is 415 volts, yeah, for 390 volts. They are balanced. But can you give a guarantee at this time, Sarang, all the three-phase are equal voltages? You go and check in the multimeter, check the voltage between Rn, Yn and Bn, you will find it is never equal. You will get in one Rn it is coming 380, Yn it is coming 390, and Bn it is coming around 385. It is not balanced. If it is not balanced, so you will get a zero sequence. You will also get a negative sequence. So that is the reason your induction motor is not running at a rated speed. It is running less than that, or there is some turbulence in it. But since we are doing in the laboratory, we are not able to see that precision. Otherwise, smooth variations can be seen with the equipment, proper equipment. We can see that whether there is a flickering or not. Okay. Then this three-phase unbalanced supply, if we will give to induction motor, how to calibrate it, how to understand that. So what we will do, if there is an unbalanced voltage, whatever the voltage is there, convert that voltage into positive sequence, negative sequence and zero sequence. Why? Because you know this is the God side. Positive sequence matlab ye positive sequence hai, it is rotating in the clockwise, all are balanced. अभी हम लोग पढ़ाई करेंगे what is the effect of positive sequence on the induction motor. Actually we have actually studied what is the effect of positive sequence. What is the effect of negative sequence? We will see what is the effect of negative sequence. What is the effect of zero sequence? Sir, zero sequence का कोई effect नहीं है. क्यों? Sir, तो co-phasor term है. Co-phasor term तो flux rotating flux ही नहीं produce करेगा. बिना rotating flux के कारण आपका torque produce होगा ही नहीं. So what is the effect of positive sequence? What is an effect of negative sequence? How does the torque varies? That we will study now. Just after 5 minutes. ठीक है? Those students, those who are attending online. Okay. So I think all the students are there online right now. If they are online, so I will suggest that I don't have a time to send a link right now because all my devices are occupied. Uh, so you can simply put your roll number there. Don't give your okay. You can put a roll number there. I will hide the chat box once it is uploaded in the YouTube, so that your privacy will not be hampered. Then we will collect the attendance as per that. Okay. So, but you must be attending the class. If you are attending the class, so okay, you will get. Apart from that, let me just review what we have learned in this 1 hour. We learned about what is the effect of third harmonic, fifth harmonic, seventh harmonic, ninth. What are the effects of harmonic, and how? What is the value of the slip? What is the value of S3, S5, S7, S9, all those things? What is the value of slip in terms of the S? And also we learned about what is the positive sequence, negative sequence, and zero sequence. What is the effect of unbalanced voltage on the induction motor? So how to learn that? Any unbalance, we have to convert that into positive sequence, negative sequence, and zero sequence. फिर भैया कितना पॉजिटिव है? 60% पॉजिटिव है, ओके. 30% नेगेटिव है, ओके. 60 में से 30 गया, बचा कितना? 30. That is very bad. If there is a positive sequence and zero sequence, no problem. But if there is a negative sequence, then big problem. Like I am a Brijesh Kumar is there, so he has got a positive sequence 80. Nice. But sir, you have a 15% negative sequence. So that 15% is actually cancelling mine from the 80. It is converting into 65. So my rest, just like in GATE exam, you give a positive answer 4. You give a negative answer -1. So your overall mark is decreasing, right? So that's the difference. So now we will see what is the effect of Thank you. Next, we will see what is the effect of positive sequence, negative sequence, and zero sequence. And let us only positive and negative. Only this one. Positive sequence, negative sequence. First is the equivalent circuit. In case of positive sequence, the equivalent circuit is so you can write instead of V, we can write VP. VP is for the positive sequence. याद रखो, positive sequence, negative sequence, zero sequence, these are the part of the supply voltage. It cannot be greater than the supply voltage. If I am 100, my positive sequence is suppose 80, बाकी 20 negative and zero sequence में divide होंगे. ऐसा नहीं कि negative भी 50, ये भी 50. So it is like linear addition. What is this value? This is R1, this is X1, this is X2 dash. Positive sequence, so all the terms will remain there. This is XM. What is this? R2 dash by S. Clear? This is we know. Negative sequence, what is the equivalent circuit? This is R1, this is X1, this is X2 dash. This is what? This is what? What is the slip in during negative sequence? I will do the rough work here. What is the slip here? Slip is equal to omega ms minus omega m divided by omega ms. Correct? What is the slip over here? Let us say this is the positive sequence slip. What is the negative sequence slip? Negative sequence means the flux is rotating in the anti-clockwise direction. So this is minus of omega ms, minus of omega m divided by minus of omega ms. What is this value? Quickly tell. Yes? This is 1 plus 1 minus s. 1 plus, this ratio is 1 minus s. So this value is actually 2 minus s. So can I write, instead of R2 by R2 dash by, I can write here 2 minus s. Clear? For negative sequence, the equivalent circuit is only difference is, here I am getting 2 minus s. Rest of the things are as it is. Is it okay? So this is not required anymore. So this is, you understand? Now, what is the current here? I2 dash. Usually we write I2, or you can say current, rotor current refer to the primary side, I2 dash. I2 dash is how much? Positive sequence voltage divided by Z's, root over of Z. Sorry, Z is actually root over of the impedance. So here this is Z is equal to x square plus R1 plus R2 by R2 dash by S whole square whole root over. Like this. What is I2 dash there? So I can say this is I2P, positive sequence current. What is negative sequence current? I2N dash. What is negative sequence current? Vn, this side is Vn, right? That is Vp, this is Vn. Vn divided by x square plus R1 plus R2 dash by 2 minus s whole root over. Correct? What is the difference you observe here? Here s is 0.02. This value of resistance is very high. In front of all these terms, only this is dominant. But here, different. Not domination case. Here we are saying it is dominant when it is near, S is near to 2. मतलब कहने का मतलब यह है, अगर यहाँ पर S का वैल्यू 0.04 है, ये डोमिनेंट है. बट यहाँ पर अगर S का वैल्यू 1.96 है, तब ये डोमिनेंट है. Point to be noted. Here the value of S is 0.04. Usually ऐसा ही होता है 0.04. पर S का वैल्यू 1.96 आपने देखा है? देखते हैं. Let's see this. Speed torque characteristics of induction motor here. How does it look like? Speed torque characteristics. If I say positive sequence, x-axis torque. Y-axis omega m, this is omega ms. When the motor is running at omega ms, what is the value of slip? S is equal to 0. What is the value of slip here? 1. What is omega m here? 0. Now if I go down, at this point somewhere, the value of S is equals to 2. But omega m is minus omega ms. Here omega m is minus omega ms. Is it okay? Negative speed. So this is the waveform, this is the characteristics curve for the positive sequence. What will be the characteristics curve for the negative sequence? The characteristics curve for the negative sequence will be like this. So one is for the positive sequence, one is for the negative sequence. You will find at S is equals to 1, when the value of S is equal to 1, the starting torque here and the starting torque here both should be same, because starting torque means S is equal to 1. If S is equal to 1, both the currents are same. Here S is equal to 1, this is R2 dash. Here S is equal to 1, this is also R2 dash. So both are equal. So for that reason, let me just remove this. So this is what the value of the current. Clear? What will the torque? The torque will be equals to torque for the forward motion, TP, will be equals to 3 by omega ms Vp square, or let me write down clearly, I2 square, I2P square into R2 dash by S. Can I write like this? Is it easy to understand? 3 I2 square R, I2 square dash, sorry, I2 dash divided by S. What is the torque for during negative? 3 by omega ms I2n square R2 dash by 2 minus S. Can I write like this? So that means we have a positive torque and negative torque. In negative torque, synchronous speed is negative. So if you can have a minus sign over there, so you will get a negative answer. So what is the total torque here? TP plus Tn. So if I write here, total torque is equals to TP plus Tn. So this will be 0 when S is equals to, at S is equals to 1, T is equals to 0, because the positive torque and negative torque is 0. क्योंकि जब S का value 1 है, if we can write like this, the value of T when S is equal to 1, this whatever the positive torque, same is the negative torque. So this term will be equals to 0. You can see in graphically here, जितना positive torque है उतना negative torque है. This is the torque axis. Okay, let us say the motor is running in a positive sequence. The flux is there in a positive sequence and there is a load. How do the load we can draw? Let us say load is a straight line. So where is the intersection point? You can say, sir, intersection point is this. So where the motor is running actually? Motor is running at this speed. For this load, the motor is running at this speed. Now if because of some disturbance there is a positive and negative sequence will come into picture, तो ये negative sequence आपको नजर नहीं आएगा. कैसे नहीं आएगा? क्योंकि अगर इस टाइम पर यहाँ पर पॉजिटिव सीक्वेंस का टॉर्क इतना ज्यादा है, नेगेटिव सीक्वेंस का टॉर्क बहुत ही कम है, तो व्हाट विल हैपन if because of some disturbance, unbalance will, suppose motor is running, motor is running because of supply voltage. Unfortunately, there is some problem in the unbalance occurred. So what will happen to the motor? Motor will not be 0. Motor will just run in a different characteristics. Which characteristics? It will run like this. The characteristics will, it will run in a little bit of like that. It will decrease because there is a sum of yellow line and the blue line, and you will get another line. Every point there is a sum of the yellow line and the blue line, and you will get like this. Let me give an example. Suppose you are using you are having a fan. Capacitor is not working. So घर में क्या करते हैं हम लोग? By default, what we do, we just give a little bit of torque in the clockwise side. If we give a clockwise side push, so it will rotate in the clockwise direction. कैसे होता है? क्योंकि if a single phase supply is there, it is induction motor, single phase induction motor. If you give a single phase supply, the single phase supply can be resolved into two synchronous flux, one rotating in the clockwise, one rotating in the anti-clockwise. The clockwise will create a speed torque characteristic like a yellow line, and the anti-clockwise will create a speed torque characteristic like a blue line. Summation of these two at the starting point is 0. That is why you need a capacitor, you need some kind of starting torque. If you give a starting torque, the motor is here. If the motor is here, the yellow is greater than the blue, and you are getting a torque. That's a simple thing. Okay? So what you learn about what is the effect of positive sequence, what is the effect of negative sequence. Okay, we will stop here. We'll stop here and some discussion. Then next class we will. There are other things also. Speed control of induction motor, variable frequency we have discussed. Slip speed we will need to discuss more once more, right? Okay, those who are in online, so thank you very much for attending the class and be here. I hope you have given your roll numbers, all those things, some kind of thing in the chat box, which will help me to collect the attendance from this online mode. So we are going to close this session here. Thank you.